Good morning. So it's great to be here with you at OpenSearchCon, and great to be in Berlin and enjoy some of the benefits of the live music scene in Berlin last night as well. We're going to be talking about RAGElo together with Fernando. So I'm the founder and CEO of the company. Fernando does all the hard work. So I will do the introduction, and I want to kind of guide you through some of the thinking with all this recent generative AI and large language model revolution that went into our evolution of RAG. Does everybody here know what RAG is? Retrieval Augmented Generation, right? That's the way to deal with up-to-date or proprietary information in LLMs. And you can do lots of things, and we kind of evolved from fine-tuning these kind of models in a certain way to put a lot of emphasis on evaluation, and that's really what RAGElo is about. RAGElo is an open source toolkit that we authored and that can serve to compare and evaluate RAG models. And we also want to take you a little bit into our thinking where things are going. And we think that this kind of automated evaluation can also play a large role in the further evolution of LLMs into more agentic systems. And that's what Fernando is also going to be talking about. So for those of you who haven't heard about us, we're Zeta Alpha from Amsterdam. We've been working on neural search and generative AI since 2019. Our focus is really kind of in the knowledge management space to make internal information accessible in large companies which are very R&D or technology intensive, like, for example, BASF and Festo here in Germany. So basically, LLMs have enabled this new paradigm of search where you're no longer looking at the documents, the search results, but you are formulating an answer directly as a response to a question. So sorry for our hosts from Amazon, but this is a relevant question for many startups. Especially when you're in the AI space, you use a lot of GPU. So now and then you ask yourself, how can I best reduce our costs for these cloud instances? And of course, you don't want to read through every document that matches these keywords, but you actually want to get an answer with pointers to the right document. Or to connect to the person who wrote that document, because you need to ask them some more questions. So the pattern extends a little bit because you can also chat to individual documents, right? Not the whole collection. So you can. This is a very good productivity use case where you can quickly get a summary of a long document and ask pertinent questions, and then get answers from the document with pointers to particular passages in the document. And it's very nice that you can also do that across different languages. So this is the AI policy guideline from China. So I want to know what it says. Ask the question and give me the summary in English. And it's not restricted to text. It's you can also do it with images, because the underlying large language models are no longer large language models, but actually large multimodal models, and they take images and audio and video input as well. So our platform is centered around OpenSearch. Actually, we're super happy that OpenSearch so quickly provided a very capable vector search in the early days when other Lucene-based search engines didn't have it yet. And not only that, but obviously there's a lot of new vector databases, but OpenSearch in our mind provides a very nice combination of the modern vector search capabilities with everything that you need to manage your search indexes and at scale, and also to combine more classical filters and schema and relevance engineering with these modern things. So our platform provides an ETL pipeline to connect to different document sources, familiar applications like Slack or SharePoint, Google Drive, etc. Processes them through vectorizer, typically a Hugging Face open source sentence transformer model or similar, and then does the same thing for the queries and provides on top of that APIs for not only search, but also question answering, chat, and other kind of bot types or agent types. So the star of all of this is Retrieval Augmented Generation. So basically, you can ask a question to a large language model, and if it doesn't have any external search engine capabilities, it will answer from the data that has been trained on, which is typically all of the public internet until a certain cutoff point. So that will not make it do very well when you ask a question about data that's not on the public internet or that's more recent. And first people thought, well, we need to continually fine-tune or kind of retrain these systems. But over the past year or so, it has turned out that actually just attaching it to a search engine and sending the query to the search engine and then templating the top results from that search engine into the prompt together with the original question and some good instructions, allows it to answer questions from proprietary data, from up-to-date data, and there's no need for retraining. All right, so that's basically the RAG pattern. This is how it typically looks under the hood. So you have some instructions giving the following extracted parts of a long document and a question, create a final answer with references. If you don't know the answer, just say you don't know, etc. And then you paste the question and the search passages. So you can imagine that if your search is not optimal, which it never is perfect, right? And you template 5 passages from your search engine into this template, there is a risk that it will still hallucinate or kind of embellish or improve the answer a little bit with some irrelevant facts that are from the wrong documents. So there are other more refined patterns. So there's this idea of chain of thought, where you first ask the large language model to reason a little bit about how it's going to come to the answer, decompose the steps, and then give the final answer, which gives a lot of improvement in question answering. It also gives a lot of improvement in RAG. So you can ask the language model to basically first kind of reason about the relevance of the individual documents and kind of discard the information from the documents if things they're not so relevant. And that gives a lot of improvement, actually. Generative models are kind of linear in the length of the generated text, so it also adds a lot of latency, unfortunately. So if you're interested in RAG, this is a good overview paper, fairly recent from January this year, and it kind of divides these approaches to RAG in naive RAG, which is the most basic pattern, just templating the passages. This more advanced RAG pattern, which does some maybe some pre-processing on the query, etc., on intent recognition and query rewriting before retrieval, and then some reasoning or re-ranking or summarization on the retrieval results after that. That's the second prompt that I showed. And it's evolving into more and more complex systems where multiple LLMs are kind of debating about the validity of the answer or providing different perspectives. And that's kind of the agentic or modular RAG pattern. So, of course, there are a lot of open source toolkits that are good for implementing RAG or experimenting with it. LangChain is a very popular one. Llama Index, DSPy is a pretty recent one, which is very nice. And also here from Germany, Haystack. They kind of promise that you can get started very easily. Well, 5 lines of code, I'm not sure, but This is an example which actually works. But that kind of leaves out the question of quality. How good does it work? Like you get a proof of concept, you get a demo that kind of works. But of course, if you want to, in a company context, provide a chatbot or a question answering system for internal technical support or for expertise retrieval from old research reports to research scientists, that's not going to be enough. And what's important to realize is that, of course, never before has search relevance in your top 5 been so important in some sense, right? Enterprise search systems have not been that great over the last decades, but everybody was like, yeah, I'll use Google if I need to find anything. But now, as people are starting to deploy these chatbots and generative AI systems in companies, all of a sudden the relevance of the internal search system becomes really important. So we have kind of a new mission, precision at N, precision at 5 typically. And keyword search is not going to cut it, because if I want to answer this question, I don't want to get a document which tells me how to reduce my travel cost. But maybe I want a document which has very little keyword overlap, and so you need semantic search. And that's basically why vector databases and neural search have really become very popular in this use case. But these embeddings are very generic, also trained on open web data. So we want to look at fine-tuning. And basically fine-tuning means moving query embeddings closer to relevant documents and further away from non-relevant documents. And this is kind of a way to learn domain-specific terminology in a domain of expertise that's relevant to a company that is creating the chatbot. But the problem in enterprise search, unlike in web search, has been that we have no large amounts of click feedback. We don't have supervised training data. So we developed this fine-tuning approach. I already mentioned it yesterday in the Young conference. That's called in-parse, which basically in-parse stands for inquisitive parrots. So that's why parrots. And basically the idea is to leverage unsupervised data, so the documents that you have in your index, slice them into passages, and then use GPT or some other large language model to generate synthetic queries based on a few so on a few examples. And this way you can easily generate 10,000 or 100,000 query document pairs which are relevant to each other. So these are your positives, you augment them with some negatives, and you can fine-tune your models. Actually, there's a little bit more to building a performant RAG system. You probably need a hybrid between keyword search and this vector embeddings. You need to combine the results with rank fusion, maybe do a bit of re-ranking on top, and some other modules in between. So there's a lot of gain to be achieved there. So, for example, in the left-hand side diagram, we start with a baseline of just neural search using an older embedding model. I think it's all MPNet, which is not so good on English, about 30% precision at 10. On German, it's even worse. This is on a chemical domain data set from one of our customers. And you see that by switching to a more modern embedding model, E5, and then fine-tuning that on these synthetic data, adding a re-ranker, adding hybrid on top, fine-tuning the re-ranker, etc., you actually go from about 30% on English to about 80% precision at 10. So that's very significant for the trust of the users in the answers from the system. In the right-hand side diagram, you see another use case matching people and jobs. So the query is a job and the documents are CVs, resumes. And here you also see the light blue is OpenAI ADA embeddings out of the box. E5 multilingual is the dark blue, and then if you fine-tune on this synthetic data set, you get the orange one, which is a lot better. So that's great. You have all these knobs to turn, but there's so many combinations, right? And so with LLMs, prototyping these kind of systems is super easy, but evaluation has become very hard because you need to basically, in the old paradigm of search relevance tuning, you need to get users to annotate the data sets for you. And you have all these different embedding models, you have different prompts, small changes can make a big difference, even like how you write square brackets, or you have different LLMs, different vendors, different speed and size and all that. So we were thinking maybe LLMs are not only the problem, but also the solution. And that's what Fernando is going to tell you about.
Thanks. So when we go to a company, they might have a problem that they are working on a POC for a RAG solution. And the first thing they say is, OK, we need a good search, right? Because garbage in, garbage out. So what's the first step there when you come to this company is, well, we need a baseline. So the first thing to do is to understand what are the important queries or query types that people have. They might have some log data from maybe previous search system. Maybe the product owner can come up with some few queries and so on, but they might collect, I don't know, like 20 or so queries. Is this good enough or not to have some, good evaluation? Not clear. Okay, but then we continue there. We send these queries to a baseline system, and we evaluate. And so typically, you can ask these domain experts a few times for manual annotation, and that they might be excited at the beginning because they're excited about AI and the potential there. But at some point, they would just say, OK, sorry, I don't have time for this. And then we are just asking me every week for new evaluations. OK, please don't bother me anymore. So coming from this in-parse experience, we thought, OK, one of these issues is the generation of the queries for benchmarking, right? So we thought, what if we ask the LLM to create this data, right? Because normally you have already some benchmarks in the public domain, but they might not correlate with the type of data that you have in the internal company. So one of the things we could do is just say, ask the LLM, OK, you have this document, please produce for me some relevant query that could be relevant to the passage. On the other hand, on the evaluation side, you can also say, well, we have this query and then we have this answer. How good is this answer? The problem is that the LLM is not an expert, right? So the LLM has been trained with a lot of data, but this type of companies that we work with, they are very high technical, and a lot of the secret sauce is internal. So LLMs may not have seen any of this information before. So normally, the quality of the evaluation from an LLM is going to be very poor. But what we notice is that if you compare across different versions, it seems like the human evaluation and the LLM evaluation correlate. So you can see in this graph, for example, this precision at 10. And we ask human experts to say, OK, please evaluate these answers. And then we ask also the RAGElo tool, which I will introduce in a bit. And then you see that, for example, RAGElo is a bit more lenient. So it says that answers are better. But overall, they kind of correlate, right? So it says version 2 is better. If the human says that, then the LLM also agrees. So this is we developed this tool, which is open source. You can use this QR code if you are interested. And I want to dig a bit deeper on how this technique works. As mentioned before, the LLMs overestimate the relevance. But when you have multiple queries, then it seems that they kind of agree on like which is better than the other. Of course, there are some questions that you can ask. For example, maybe the LLM is biased, right? For example, if the LLM created the answer, could it be biased to say, oh, my answer is better than another LLM, so maybe we should use different models between evaluation and generation of the answer. And also, like, what are data sets that we can use to validate this, right? I mean, if you are saying maybe like, is this like scientifically correct, right? Is wanting to see some correlation, but is there something in behind there? So maybe we need to find some bigger data sets where you can say, okay, is this technique actually potentially correct? We have done internally some of that. These are 4 use cases, and we have different kind of metrics that we're measuring, MRR and DCG and precision. And we see that, generally the blue line is the RAGElo, the LLM annotator, and then the orange is the human. And you see that all of these cases, they seem to agree that one thing might be better than the other. Of course, they don't agree on how good each of them are. So, okay, so I want to now dig deeper into what is this RAGElo business. So first of all, RAGElo is made of 2 parts, RAG and ELO. So what is ELO? If you follow chess or you have heard about chess, there is this ranking system, right? So you have like the grandmasters at the top, and then people compete to be there. So ELO is some sort of score that players get by playing against each other. And if you look at Wikipedia, it's some very complicated formula, but there is a simple way to understanding, which is if you play against a player and you win, if that player has a higher rating than you, you will get some amount of points added to your ranking. Now, if you win against a player that has a lower rating than you still get some points, but not as many as with the other player. And kind of mirror image with losing, right? So if you lose against a player that is higher rated than you lose some points. But if you lose against a player that has lower rating than you, then you lose even more points. So that's kind of the idea of ELO and how you can rank the players by the rank. So how does this RAGElo process works? So on the first thing that we need to do is to extract the data, right? So on the left, we have a bunch of queries that we have generated, or maybe the clients have given to us. We have a RAG system, and this RAG system is made of different, let's say, parameters, the LLM that you chose, the embeddings that you chose, re-ranking, retrieval strategy, prompting, and so on. So let's say this is one version. You can have many of those. And then you put the queries against this system, and then out you get answers, as well as context, because it's very important that when you have an answer, you want to validate whether the answer is based on the context or not. So typically, the LLM will come up with some citations, right? It will say, okay, according to this document, this is the answer, and so on. So we collect these 2 things. And now feed that to the RAGElo toolkit. So the first thing what we do on the top is that we want to evaluate for each query and document how relevant the document is for the query. So it's basically saying, is it very relevant, somewhat relevant, or not relevant at all? And then we feed this process into the next step. The next step is now we have, let's say, 2 answers from 2 different systems. Based on the previous evidence, which is which documents are or not relevant, we ask the LLM to tell us which answer is better and why. So typically, the reasoning that it gives is, the answer B is better because it mentions the topic that the user is asking, and then is very thorough, and then and so on, right? So it has some explanation. And then it gives you the winner of the game, right? So it's like if you think of this as a chess game, you have answer A and answer B. These are competing players, and the LLM is deciding, okay, B is a winner here. So we play these games for all of the systems and the queries, and then we create this ELO ranking that I explained before. And then you basically the one that is on top is in some sense the best, right? So a bit more in detail, if you want to try this, I mean, as I mentioned before, this is open source, so you can just download it and try it if you are working on some RAG system. I just want to give you some more context of what you need to fit. It's not very complicated. So the first thing that you need is to collect some queries in a CSV format, so very simple. Then you collect some retrieve documents from these queries. So you have passing this to your RAG system, but hopefully it gives you out some relevant documents, and as well as the answers, right? So for each of the queries, you have version 1 of your RAG system, and then the answer, version 2 of your system, and the answer, and so on. And then you need to write some code, or there's a CLI as well, but maybe it's easier to look at the code. The first step is to say how relevant is this document for my query. Here is one of the prompts that we use. So it's very simple. So basically it's saying, OK, tell me if it's relevant or not, or like not relevant, somewhat relevant, or very relevant. We tell the user question, and then the content that was returned. And then in the code, you see that we initialize an LLM provider. In this case, we are using GPT-4 Turbo, but you can use any other provider, open source, for example. We read the queries, and then we pass this. This is called the reasoner evaluator, where you point to the CSV for your documents, and then the output CSV, where you will get the reasonings. So this process runs in a batch job. It's depending on the size of your CSV, it may take maybe a few minutes. And the output of this process is this retrieve docs reasoning. So you can see, for example, here it's saying QID 1. The answer is very relevant. And then it will tell you, OK, it's relevant because it addresses the user question by discussing these metrics. This was a question about metrics for evaluation summarization. This by itself is very useful. So if you want to dig into the explanations, you might understand what the LLM is really focusing on to say whether something is better or not. So this on its own is very, very useful. But then we can feed that to the next step, which is now we want to evaluate pairs of answers. So the prompt, again, is very simple. It's maybe a bit lengthy because we want to tell the LLM that there are many factors that it needs to evaluate for the answers. But basically, we are saying, OK, you have a bunch of documents that are relevant because of the previous step, and you have the assistance A answer. And then next, you have assistance B answer. And then on the code side, we just say, OK, point to the CSV that has the documents, the CSV that has the reasonings, which was the previous step. And then we add some factors there that we want to evaluate. For example, in this case, we want to evaluate comprehensiveness, correctness, helpfulness, and so on. And the output of this is another CSV file, which tells you, OK, for the query 1, the agent A versus agent B, which one is better? So in this case, is agent B, and then it will tell you why. So in this case, I'm cut it because it's a bit long, but the point was that agent's A response is very brief, whereas the other one is more comprehensive, and that's why I decided B is better. Then the last step, OK, you have collected all of these CSVs. Now you want to just create a ranking, so you run this command, and then out comes the ranking. And here is telling you, OK, the version 1 is the best one, and this is the score. And the second one has a lower score. Don't need to focus too much on the numbers. The important bit is the ordering, right? So you're just saying V1 is in general better due to this process. And here I just want to show you some actual example. So here we were actually comparing a bunch of different agents, I think around 7 or so. And you can see, we identify 3 of them to be like the top. And these are the ones that we recommended the client to use. So this was about evaluation to know which agent to select. But we actually found another use case of RAGElo, which is to be part of the RAG system. And so on this next part of the presentation, I want to explain a bit more like these more advanced use cases for, sorry, these are more advanced RAG systems. The problem there is that we want to, so normally RAG systems, you feed some top 5 documents and you get an answer, but what if you want to get all of the topics about certain, all of the projects, let's say, about X? Or like in the past, researchers have done some projects and then tell me everything that this team has done. If you only have top 5 documents, unless one of these documents has all of the summaries, you would probably not get it. So we need like some more advanced technique. So one of the techniques that is very, very recent and the hot thing is called RAG fusion. And here what you do is that you ask the LLM to create, from the original query of the user, you create multiple queries that are related to each other. You get some relevant documents out of those queries, and then you do this reciprocal RAG fusion, where you select, let's say, the top 5 of this new ranking, and then you feed that to the LLM. And the hope here is that by generating these maybe related queries, you might get documents that the original query may not get, and this could be potentially useful. So there are some limitations there. For example, the LLM may not know the domain that you are trying to get the queries, so the queries may not be very relevant. So the next step in the complexity is that maybe we can use RAGElo to first evaluate whether the documents that we retrieved are relevant to the original query or not. Right? So in this case, we're actually using RAGElo as part of the RAG system, and this improves a bit. Because now we're not going in these tangential directions, right? So we're making sure that the document that we select and the feed to the LLM are actually relevant. But there are still some problems, right? Because if the original queries are not relevant, well, then you will not select any of them. So what we thought is to do this in steps, right? So we have first you generate some queries. You evaluate the quality of them, you get an answer, you ask the LLM to say, okay, do you think you need more, or is this good enough? And then the LLM might continue and say, okay, please give me more queries that are related, and then it gets another answer, and so on. So it's kind of this refining process. So this is what we call the RAG fusion agent. So it's basically this process, but done again, right? So we first generate some answer, we feed that back to the system, and then we ask for more queries, we generate more answers, and so on in this recursive process, and at some point it has to end. So there are so many open source projects that allow you to do this, so this is very simple, but there are, as Jakub mentioned, we're going away from this, right? So it's not really 5 lines of code. You need something like a bigger platform. And what we were thinking is maybe we can have, maybe we can still let developers create these complicated RAG agents, but we want to kind of help them, connect with the data pipelines that we already built, and connect with the RAGElo system that we already built, right? So we are thinking in this direction, whether we as a community, by open sourcing these tools, that how can we connect to the existing platform that already exists. So we are now working on this called the Agents SDK. So if you are interested in this direction, please come talk to us in our booth. And I want to conclude because I'm running out of time. So the conclusion is that the RAG is a good solution for helping companies that have internal data answer questions, because this documentation is not public, right? So LLMs have not been trained with this data. So this is a good and cheap solution. Typically, companies cannot fine-tune these big large language models because they are very expensive. So what we can do to help them is to improve the R part, right? So create pipelines that retrieve bigger quality results so that they can use in the systems. Evaluation is very important, right? So it's very easy to produce these variations of systems, but it's very hard to connect back to the business and making them understand why is this better than the other. So evaluation is the key. Yeah, thank you.
And both Imparse and RAGElo are open source, so check it out and go play.
We still have some extra time. Would you like to field any questions?
Yes.
Or, oh yeah, are there any?
Thank you so much for the talk. It was very interesting, and I really enjoyed it. I had a couple of questions about the Imparse and RAGElo. So when you use the LLM, so for the Imparse, actually both of those questions is how do you know that the LLM doesn't actually doesn't have inaccuracies? For example, when you create synthetic questions to train, for example, if, I say, my name is Sam, and the question is your name Sam? Like, it can embed the keyword in it. So maybe that can cause some drift in the accuracy. And for the RAGElo, the relevancy was also interesting to me. Like you need an LLM that is good at evaluating relevancy when you try to judge, right, between two answers. So if the LLM is not familiar with the private data, how can it be a good judge? And how would that explain the good results and the correlation we were seeing? So that's.
So maybe I can answer that. So I think we all agree that the LLM has a sort of a pretty good general capability with language, right? It has a way with words and a bit of reasoning, which is not too deep, but it's pretty decent, right? In many languages. So when the explicit information is in the prompt, it's very hard to get it off the rails in normal situations. So if you look at the synthetic questions, we of course, the ultimate judge of relevance or accuracy or truth is the human expert. So of course we evaluate that as well. And if you look at the synthetic questions, they're almost 100%, like 99%. The question is actually about the passage. They might not be very useful, so that we have some special ways of filtering out the unuseful ones, but they are good positive pairs. Of course, measuring how the fine-tuning affects the retrieval metrics, there RAGElo can be useful to select which system is better than the other, but not to give you the actual score on precision at 10. That still has to come from a human expert.
And of course, like the LLMs do understand some of the domain, right? So for example, in chemistry, they understand basic chemistry, maybe not at the level of the company. So when they see the answer, it's sometimes enough to understand whether it's correct or not. But I agree that if the gap is too large, it's probably not going to have a good answer. Like, it might just say, well, the keyword is mentioned, but maybe it doesn't understand what the keyword means.